Hope good afternoon to one all. I'm Anurag Deulkar. Hope I'm audible and my screen is visible to all of you. Yes, Satish, Daire. Is my screen is visible and I'm audible to you?
Yes, sir.
Thank you. Thank you. Yeah. So let's start the session. So, dear friends, in this session, we'll going to discuss about logarithmic and exponential. So, generally, this logarithm and exponential is concerned. It is not a new topic for all of us. We have gone with this many times, especially in our 12th. So, let's start. So, the today contents for this program will be logarithm. First, we'll discuss about the concept, formulas, key point, and numerical. Yes, so let's start with the basic concepts. Friend, as far as logarithm is concerned, so there is a very clear and clean analogy in between logarithm and what we can consider it as exponential. So logarithm and exponential is an opposite, basically a way it is connected. So first we start with the logarithmic concept and then we'll go with the exponential one. Okay, so if we are considering a as a positive real number, positive real number means, my friend, we are considering from 1 2 3 4, or it will be, or in points we can consider real number other than 1, and it is having some power m. Okay, it is also a natural number, a to the power m, and if it is equal to x, means some real value, then we can consider it as m equal to log to the base a x. Are you getting? So now with this equation, with this two thing, which is one is exponential, another is log, you can consider, means they are very much related, my friend. Okay, so whatever I have mentioned in this statement, that you can understand with example, because as Einstein greatly said, if you want to understand anything, example is the only way to understand it in a good way, friend. Yes or no? So like if suppose we are mentioning like a to the power m equal to x, it is considering like 10 is to power 3. 10 is to power 3. We know that 10 is to power 3 is equal to 1000. Yes or no? So if 10 is to power 3 is equal to 1000, this you can consider log to the base 10,000 is equal to 3. So my friend, I believe you can understand the analogy in between these two. You can simply understand the analogy in between these two. So those who is the answer, those is in the terms of answer, we are taking the log, okay, and whatever we have at the base, okay, that is what it is there. So whatever you are putting at the power, which is considered as surds, okay, that will be your answer. So 10 is to power cube equal to 1000 can also be represented as log to the base 10,000. Are you getting? So with this you can solve many problems. Okay, I hope you are getting my point. Like here, if you see 3 to the power 4 is equal to 81, that we know. But if suppose if someone is telling us that tell me log 81 to the base 3, log 81 to the base 3, that we don't know. But with this analogy, you can simply understand how it is going to considered. So log to the base 81, log 81 to the base 3 is equal to 4. Similarly, 2 to the power minus 3, that is equal to 1. 2 to the power minus 3 is equal to what? 1. And it can be considered log 1 to the base 2. Log 1 to the base 2 is equal to minus 3.88. Are you getting my point? How this analogy is simply similar, how they are connected, because this is very important point, friend. Next is 0.1 to the power square. 0.1 square, we all know that it will be 0.01. Yes or no? Log 0.1 square is how much? 0.01. Similarly, you can express this in terms of log 0.01 to the base 0.1. Log 0.01 to the base 0.1 is equal to 2, my friend. How much? Is equal to 2. So hope you are getting this relations. Okay, so this is what the base, my friend. You must understand this thing first. If you clearly understand, then only you can have a good command on this particular concept, which is considered as a logarithmic concept. Okay, because this type of question asked many a times in the GATE exam. So just note it down, this relation. If a to the power m equal to x, it is given, then it is always can be considered at m equal to log x to the base a. Okay. Now, generally, whenever we are considering logarithm, so if you understand or if you learn or if you remember these properties, so 50% work has been done. Hope you are getting my point. 50% work has been done. So if not, then there will be trouble. Okay. So you must understood this property thoroughly. Okay. So let's discuss this thing. So the first property, this we all know, that if suppose there is a product of two real numbers with respect to the log to the base something, it can be considered in terms of summation form. So log xy to the base a can be considered as log x to the base a plus log y to the base a. Hope you are understanding. Okay, log xy to the base a can be represented as log x to the base a plus log y to the base a. Second is log x to the base a. Log x to the base a can be represented as, this is new one, my friend. This red one is somewhat which you don't know, but the in the GATE exam many question has been asked in this, but is in this one. So just go with that. Very important. Okay. So what this property said, that log x to the base a is equal to log x to the base a minus log yy to the base a. Now friend, yy is simply in a multiplication file and y is simply a real number. So don't consider that y will be 2, so y will be 2. No, nothing. It is simply considered the same nature of number. Okay, it is not y into y like 2 into 2. No, don't confused. So y into y is considering a real number, which can be anything like 2 into 3 or any number. But this can be represented in that form. So what is the second property? It is log x to the base a is equal to log x to the base a minus log y into y to the base a. Okay. Now third one is log x to the base x. Log x to the base x is equal to 1. Log x to the base x is equal to 1, and that is equal to log x. Now why this log x to the base x we are representing 1? Because you know there is simple basically concept that if there is log x to the base x, so this base x can be represented by log x. Are you getting? So we know that log x upon log x, that is always equal to 1. So this is what. Next is log 1 to the base a. If suppose we have some real number here and log 1 is there, so we all know log 1 is 0. Why? There is a real, again point that if suppose a is your positive real number, very important my friend, if suppose it is negative real number like -1 or -2, it not be 0. Please remember it. So log 1 to the base a, where a should be a positive real number, then it is 0. Why? Because it can be represented again as log 1 upon log a. Similarly in this fashion. Hope you are understanding. Yeah. So log 1 to the base a, where a is a positive real number, then only it is equal to 0, my friend. Okay. So we are mostly basically what we do, we always try to have, we always try to mug up. Okay. So okay, so this you can understand in a very conceptual manner. Please note this. A is your positive number. If suppose A is having something different, like any different word, then it is different. Okay. So log to the base -1 to the power 1, it is not equal to 0, my friend. Please note it. Next, log x to the power n to the base a can be represented as, and this is simply indices answered. We have note this thing. So whenever there is a power with respect to the log, that always come at front. That always come at a front way, my friend. So it is always n log x to the base a, and this also can be represented as n into, please, one more step I'm deriving here, n log x upon log a. Hope you are getting. So log x to the power n to the base a is equal to n log x to the base a. Here what is there, what is happening, whatever the power is there, it is coming at the front. Okay. So and that can also be represented as n into log x upon log a, because see, this methodology will always be used in a formulas, in a numerical whenever you're solving. So please, if you understanding these properties, if you are learning these properties, then again 50% work is done from your side. Next, log x to the base a, log x to the base a is equal to 1 into log x to the base a, friend. Okay, and it can be represented as log 0 into log a. Hope you are getting my point. So this is again a different analogy. Understand it. So log x to the base a, log x to the base a is equal to log x to the base b. Log x to the base a equal to 1 into log x to the base a. So why we are putting 1? Because we all know if something, if it is nothing written here, it is always 1, and 1 is nothing but what? Log 0. This 4 property we are using in 6. So understand it. Next, 7th one, my friend. Again, it is also important. Log x to the base a, if it is something written where a is a positive real number, and that is equal to log x to the base b. That is equal to log x to the base b. It is equal to log x into log a to the base b into log a. Okay, log x to the base a equal to log x to the base b equal to log x into log a to the base b into log a. This is very important property, friend. So understand it. What they are telling, if both having the same number, if it could be natural number, it could be real number, whatever it may be, if it has, and the different base is given, then it can be represented at log x into log a to the base b into log a. Okay, so this is what the output. Okay, so just understand it in a good way. Okay, just note it down. I'm giving you 2 minutes. Please note it down. Very important. So hope you have noted down. Very important, friend. Let's go with another basic one. So a concept it is called as common logarithm, and it is very simple one, but yes, it is very important one as well. The logarithm to the base 10 are known as common logarithm, my friend. Okay. Now the logarithm of a number contain two parts, namely characteristic and mantissa. This you should remember. This point is very important. Okay. So the logarithm of a number contain two parts, namely characteristic and mantissa. Okay. So the decimal point of a logarithm, what I'm telling you, the decimal point of a logarithm is called a mantissa. 1 mark basically question was asked in GATE for on this. So try to get this point as well, that which is called mantissa and which is called characteristic, friend. Okay. So see here, here it is an example. It is given that suppose log 2. Now here base is nothing. Here no base is given. So again you can consider as log to the base 10. Hope you are getting my point. Yes. So it is considered as log to the base 10, and that is equal to value is 0.3010, friend. What is the value? Value is 0.3010. Now here the mantissa is 0.3010. Okay, this consider as mantissa, and characteristic is here, left side of decimal point. This is called as characteristic. Okay, so these two words is very important. Please understand it. Next, friend, let's discuss some numerical which is asked many a times. The first numerical is, what is the number of integral digit n for log 200 that is equal to 2.3010? Now the question asked us is, you need to find out what will be the number of integral digit, means what will be the value of this n for log 200 that is equal to 2.3010. So here is the simple thing. Okay, this is very simple numerical, and it is given in a very reputed book, okay, of your 12th. So most of we cannot go with the book and all. We simply put the notes, and that's what the reason our basic are always not clear. So here is the question which is asked in GATE, and very important, friend. They have asked you about the find out number of integral digit, and it is for 2 marks, and it is so easy. Okay, why? Because it is a basic one. What is the number of integral digit n for log 200 that is equal to 2.3010? Now here mantissa is 0.3010, characteristic that is 2. Now here characteristic plus 1, and that is equal to 2 plus 1, 3. Okay, so characteristic plus 1 is equal to 2 plus 1, that is equal to 3. So how we can find out the number of integral digit? We can find out number of integral digit as, this is what a simple formula. Whatever the characteristic it is given, just add it 1. What do you need to add? 1. So with this, n is equal to characteristic. And what is characteristic? Whatever the value it is given in the left hand side of decimal, that consider as the characteristic. Hope we are getting. So it is 2 plus 1, that is equal to 3. So number of integral digit will be 3, my friend. Number of integral digit will be 3. So please note down this particular point, and very important numerical from this particular side. Okay. So how you can find out number of integral digit n? That is simply given here. Okay. Next, let's discuss some more basic concepts. Then we'll go for numerical with that. So, friend, we are talking about characteristic. Okay, and what is characteristic? I already told you. Characteristic is nothing but whatever the value it is given in the log. So the decimal point left side digit is considered as the characteristic, friend. Okay. So the internal part of a logarithm of a number, is called its characteristic. This is what a simple definition. Now, it is simply analyzed by considering the two cases, which is very important. The first is, meanwhile, you just read it, these two cases. I'll explain it. Okay. So the cases is like when the number is greater than 1, friend. First, the case is when the number is greater than 1. Okay. So whatever the answer, whatever the logarithm digit, it is greater than 1. So the characteristic is 1 less than the number of digit in the left of the decimal point in the given number. So if suppose it is given 2.3010. Okay. So here left number is what? 2. So it is always 1 less than the number of digit in the left of decimal point in the given number. So it is 2 minus 1, that will be 1. And when the number is less than 1, the characteristic is one more than the number of zeros between the decimal point. Okay, number of zeros between the decimal point, my friend. And the first significant digit of the number, and it should be negative. So instead of -1, -2, etc., we write 1 bar or 2 bar, like this one. Okay, so this is what the meaning of these two cases that we should understand. Based on this, 1 mark question is asked. Now, friend, let's discuss this. A simple numerical which is asked for 2 marks in GATE 2017 exam. The question is like, which one of the following statement is not correct? Okay. The question is, which one of the following statement is not correct? So this we need to find it out. So hope this thing is clear to all of you. Very important concepts we are dealing with. Okay. If you have any problem, you can just put the message to me in a message box. So which one of the following statement is not correct? That we need to find out, friend. Okay. So anyone? Here are the options. The first option is log 10 to the base 10 equal to 1. Not correct. That we need to find out. Yeah. Second is log 2 plus 3 is equal to log 2 into 3. Third is log 1 to the base 10 equal to 0. And fourth, log 1 plus 2 plus 3 equal to log 1 plus 2 plus 3. Log 1 plus log 2 plus log 3. So which one is not correct? Yeah. Which one is not correct? Shubham, Vedant. Okay. Shubham has put it C. Let's discuss this thing. Yeah, so here is the explanation, friend. Now let's discuss one by one, because this clears our basic concept, and again it gives you a clear idea how we are implementing our concept to the system. So first one, see, log a to the base a. We know log a to the base is always 1, and this simply implies this one. So log 10 to the base 10 equal to 1 means this is correct. Okay. Second one, log 2 plus 3. So we all know that log in bracket 2 plus 3 can be represented as what? Log 5. Yes or no? But if you see the second part, my friend, this we can write as log 2 plus 3 is what, my friend? It is in bracket, so you can write log 5. But here, log 2 into log 3, what it will be? Log 6. It is what? Log 6. That log 6 or log 2 into 3 can be written as how? It can be written as log 2 plus log 3. Yes, product form we can represent it now. Yeah. So this 2 is not same. Log 5 cannot be equal to log 6. Yes or no? Log 5 cannot equal to be log 6. So log 2 plus 3 are not same as log 2 into 3. Are you getting my point? This is very important. Try to understand this concept. Very easy, but very important. Okay. Next, the question given, so option given as log 1 to the base 10 equal to 0. So as one of our friend has put it that this is wrong, but friend, if you see, log 1 to the base a is equal to 0. This is what the rule we have. Log 1 to the base a, where a is a positive real number. Log 1 to the base a, where a is the real positive number, that is equal to 0. This is the property which we have seen earlier. So log 1 to the base 10 equal to what? 0. Log 1 to the base 10 equal to what? 0. Yes or no? And that is also that can be represented in the form as log 1 to the base log 1 by log 0. Yes or no? We can put it as log 1 by log 0. And we know the value of log 1 is 0. So 0 upon anything, that is also 0. Means it is correct. This one is correct, friend. Okay. Next, let's talk about this one. Log 1 of log in bracket 1 plus 2 plus 3 is equal to log 1 plus log 2 plus log 3. So how it is? See. Log 1 plus log 2, log 1 plus 2 plus 3. If you add it, we got log 6. Yeah. And this log 1 plus 2 plus 3, you can represent it. Okay. And this log 6, basically, you can write it log 6 as how much? 1 into 2 into 3. हम 6 को 1 into 2 into 3 के फॉर्म में लिख सकते हैं. अब if you see, this is a product form and you can simply transform it into summation form. So log 1 plus log 2 plus log 3, that also can represent log 1 plus log 2 plus log 3. So again, this is also correct. So option D is correct, option C is correct, option A is correct. So which one is wrong? Yes. So option B is wrong on my friend. Hence, so option B is incorrect. So correct answer is option B. Correct answer is option B. So among you, whoever have gone through this one and understood this one, it will be very easy to get it. So I hope this numerical is clear to all. Why option B is incorrect? Yes. Okay. Yes, friend. Now let's discuss some numerical which is there asked many a times. The numerical is like, you need to solve this x to the power a upon x to the power minus b having whole to the power a minus b into x to the power b upon x to the power minus c, it is b minus c, into x to the power c upon x to the power minus a to the power c minus a, where these are all positive real number. Okay, positive real number it could be. So you need to find out what will be the answer. So here the first option is x to the power a square plus b square plus c square. B is 1, c is 0, and d is none of this, my friend. Here I have simultaneously given the answer, but I want you must understand this, how this answer is coming. Are you getting? So here the correct answer is 1. So what I am going to do, I'll tell you this means first two numerical by my own, and then you need to take your time and solve it. So friend, the correct answer is 1, but how it is, let's understand. Now if you see here, we can represent this x to the power a upon x to the power minus b to the power a minus b into x to the power b upon x to the power minus c to the power b minus c into x to the power c upon x to the power minus a to the power c minus a. Now you can represent this as this much. You can represent that in this particular format, because minus b, this is the power minus b. If you put it at numerator, it will be plus. It will be what? It will be plus, my friend. Okay, so it will be what? X to the power a, and if this term is going to be in denominator, it will be what? X to the power a plus b. Because see here, my friend, base is same. Base is same. So if base is same, you can just add the power. This is the rule of indices. Yes or no? So if the base is same, like x to the power, or I consider 2 to the power 3, okay, upon 2 to the power minus 4. If this is what the case, you can simply represent it as 2 to the power 3 into, now this, when it is going to be above, it will be 2 to the power plus 4, my friend. Now you have base as same, so you can represent it like this, and you simply add. Okay, so it will be 2 to the power 7. Okay, just analyze this, answer will be same. So here, this x to the power a upon x to the power minus b can be represented x to the power a plus b, and having the power a minus b. Having the power a minus b, my friend. Okay, so we have a plus b to the whole power as a minus b. Similarly, you can represent x to the power b upon x to the power minus c as this x to the power b plus c. Hope this thing is clear to all. Why we are writing this? This is what the explanation here. Next is x to the power c upon x minus a. Yeah, so you can represent at x to the power c plus a. And now we have this power again, a minus b, b minus c, and c minus a. Now next here again one rule is there, that if suppose we have x to the power n to the power m, yeah, so you can simply represent it as x to the power n into m. Yes, you are right. So it can be represented x to the power n to the power m is equal to x to the power n into m. X to the power n into m. Hope you are getting my point. So if that is the case, you can represent it as, so if you multiply this a plus b into a minus b, we know the formula, it is a square minus b square. Yes or no? So a plus b into a to the power minus b, it will be a square minus b square, my friend. Okay. Now, similarly, here we have b plus c and b minus c. So if you multiply it, we got b minus b square minus c square. Similarly, c plus a into c minus a. Just multiply, you got c square minus a square. Now again, my friend, if you see, we have the base same. Means we have x to the power something, we have x to the power something, we have x to the power something, and it is multiplication. So when the bases are same, you just write it at one time, and you can add all this. What we can do it, we can add all this. See, whenever you solve the problem of exponential, my friend, the basic rule always, the law of indices, the law of surds come into picture very commonly. So you must learn that values, you must go through that particular formulas and all, so that it will be easy to you to consider it. Now, if you represent his, see here, if you add it, this is what we got, a square minus b square plus b square minus c square plus c square minus a square. Now if you see, my friend, here it is minus b square, here it is plus b square. So minus b square and plus b square get cancelled. Yes or no? Yes. Again, a square and minus a square get cancelled. Yes or no? Then this minus c square and this plus c square get cancelled. So if all it remain cancelled to itself, what we get? 0. What we get? 0. So x to the power 0 is how much? X to the power 0 is how much, friend? X to the power 0 is always 1. That we know. So x to the power 0 is 1. We know this thing, and hence the option B is correct. See, my friend. I hope this numerical is clear to all. Now, here in this numerical, what the basic concept we are applying? The law of indices and law of surds. So if you are aware about that and some of the basic property, then there is no problem. You can score full marks on that logarithm and exponential, my friend. ठीक है, दिखने के लिए ये सिंपल न्यूमेरिकल थोड़े से बड़े दिखते हैं, है ना, बट दे आर वेरी इजी my friend. Okay, so please practice it and you got full marks here. Let's get another one which is also based on exponential. Okay, and this all questions has been asked in GATE thoroughly. Here is the second one. Now the question is given 1 upon 1 plus a to the power y minus x plus a to the power z minus x, okay, plus 1 upon 1 plus a to the power x minus y plus a to the power z minus x plus 1 upon 1 plus a to the power x minus z plus a to the power y minus z, and they are considering that it should be equal to p. Now p can be any positive real number or it can be a natural number. Then you need to find out the value of p. So if you are finding the value of p here, the option is given here as 1, 0, a to the power x plus y plus z, and none of this. Okay, so if that is the case, so here answer is option A, my friend, means this is correct. Now how this answer came? Let's understand it. Again, my friend, same analogy. Okay, same formulas, basic of indices and surds will be used here. See here. So this term 1 upon 1 plus a to the power a y minus x plus a to the power z minus x can be written as 1 upon 1 plus. Now a y minus x, how I can write it? A to the power y minus x. How I can write it? Yes, I can write it as a to the power y, okay, into, I can write it as a to the power y into a to the power minus x, and we'll know if the power is minus, you can represent it in denominator. So it will be what? A to the power y upon a to the power x. Yeah, see, here it is. So that simply represent that a to the power y minus x can be represented as a to the power y upon a to the power x. A simple one. So if you are representing, if you know the basic one, then you can simply represent it in your own way. Yes or no? Now a to the power z minus x, a to the power z minus x also can be represented as a to the power z upon a to the power x. Yes or no? Same analogy, my friend. Hope this basic concept is clear to all of you. So a to the power z minus x can be represented as a to the power z upon a to the power x. Now again see 1 upon 1 plus x a to the power x minus y plus a to the power z minus x. This also you can represent it as 1 upon 1 plus a to the power x upon a to the power y plus a to the power z upon a to the power y. Yes or no? Yes. Now yeah, here it is, see, it is z minus x, it is written here. So it should be not y, it should be x. Okay, this should be x. So try to understand it. Next is again 1 upon 1 plus a x minus z and y minus z. You can simply represent it like this. Okay, so where a to the power y minus z, this minus z representing, you can put it in denominator. Now if you see, friend, what we are going to do here, we are going to make this as a common base. Okay, हमको क्या करना है next step में? ये आपको जो a to the power x दिख रहा है, बिकॉज यहाँ कुछ भी नहीं है तो 1 है ना. So if this is 1, you just put the denominator common. So put a to the power x as a common here. So if you are putting a to the power x common, so this common denominator a to the power x, it comes at the actual numerator, because we know 1 upon 1 by 2. So 1 upon 1 by 2 can be represented as 2 by 1. Are you getting my point? So this 2 can be here. So similarly, in that fashion, you can put it a to the power x here. Now here we are taking again LCM. So you got a to the power x plus a to the power y plus a to the power z. See here. Similarly, here we have a to the power. Now here I need to put y common. Okay. So there we got a to the power y. Similarly, here I need to put z common. Here it is nothing, so 1. So you just multiply here by LCM, we got a to the power z. So a to the power z, here it will common. It is going to be actual denominator, it will be a to the power z. Now here, if you see, all the denominator is same. So suppose we have some value like 2 by 4 plus 3 by 4 plus 6 by 4. Are you getting my point? So 2 by 4 plus 3 by 4 plus 6 by 4, we can simply write it as 2 plus 3 plus 6 divided by 4. Are you getting my point? So same we can put it here. Now all the bases are same, so we can write down one time. And here you also write a to the power x plus a to the power plus a to the power, all it is going to be in summation. So if that is the case, you can represent a to the power x plus a to the power y plus a to the power z, and that is equal to 1. See my friend, so easy, so easy. So in exponential, if you see the question, you just get confused many times, और basically हमको question थोड़ा बड़ा लगता है तो ऐसा लगता है यार इसको छोड़ दे हम लोग. But if you do some practice, आपको पता चलेगा कि they are very easy questions, है ना? They have simple logic, and if you understand the logic and you know the basic formulas for indices and surds, you can solve it any time, my friend. You can solve it any time. It is so easy to solve. Okay, let's take another one. Just go with this numerical. And this type of question asked many a times in GATE exam. So what it is given in the question, here it is given 3 to the power x equal to 7 to the power y, and that is equal to 21 to the power 2. This is what the question. Now what we need to find the relation between x, y and z, where x, y and z does not equal to 0. Okay, see. So my friend, and here is the option: z equal to xy, b z equal to x plus y, z equal to xy upon x plus y, and d none of this. So if this type of question is there, and how we need to solve? So first, suppose 3 to the power x equal to 7 to the power y is equal to 21 to the power z. It is not 2, it is z. Okay, so first correct this thing. So consider it as k. If that is the case, so we can consider 3 to the power x equal to k, 7 to the power y equal to k, and 21 to the power z equal to k. Now here k also represents same, where it does not equal to 0. K does not equal to 0, friend. Okay. Now if that is the case, we can represent this thing. 3 to the power, a to the power x equal to k. So you can represent is a equal to k to the power 1 by x. This is what a simple property we have. Okay. If someone having some power, so you can, here it is nothing but 1. Are you getting? So you just describe, just put it or divide it by that power. So you got k to the power 1 by x. Similarly, you got k to the power 1 by a, and this is got 1 by z. Now, if we can analyze, there is a relation. What is the relation? 3 into 7 equal to 21. Here, 3 into 7 is what? 21. So if base is equal, if base have some relation, are you getting my point? If base have some relation, friend, so naturally their power also get some relation. Same relation, their power also get contribute. So now here, if you see the base is same, k. So you can, now the base is same, so you can simply write it 1 by z equal to 1 by x plus 1 by z. Here it is multiplication, so you can put it into plus form. So it can represent xy upon x plus y. So xy is nothing but z. So hence, sorry, yes. So z equal to xy upon x plus y, my friend. So this is what a simple solution. Hope it is understood to by you. Next question. Find the value of root 6 plus root 6 plus root 6 plus minus infinity. You need to find out the value. How we are done? First, whenever this type of question asks, consider it with respect to some non-zero value, and as a variable we consider x. Now, if this is the case, we can write at x equal to what? Root 6 plus x. Okay, so x square is what? 6 plus x. Now it can be represent x square minus, we are putting here, so x square minus x equal to 0. So x की value क्या हो जाएगी? 3 और minus 2. But the given expression is positive, तो minus 2 हम लोग तो ले नहीं सकते. So we get the answer to be 3. Here it is. See how we are simply solving, friend. Very important. Next, among this digits, if you see the numbers, 2 to the power 1 by 3, 3 to the power 1, 5, 6, which one is greater? Which, if you need to find out, and this type of numerical ask many a times. Okay, so try to understand this thing. If that is the question, how we can solve it? First, now here we can see that it is given some value 2 to the power. So what I am going to do, I'll simply put whatever the basically power it is given, I'll simply find out the LCM. Okay, so again LCM, if I'm basically getting, so it will be the maximum is 12. So just put it that. So 12, we can represent 12 by 3, this one. So if we are getting this thing, we got 2 to the power 4 to the power 1 by 12, this one, this and this. So if you solve it, you got this 3 to the power 1 by 4 is greater one. Okay, so this is what the simple one which is there. Now next, if p by q to the power x minus 4 is equal to q by p to the power x minus 8, find the value of x. Okay, so this is also asked many a times. So if that is the case, just write it down, whatever it is given. And then, now if you see, friend, here the value, what is given here, p by q, and here it is q by p. So you can represent at 1 upon p by q. Are you getting? So if you represent 1 upon p by q, or you can else, you just reverse it. It is x minus 8. You can represent it at minus x. Are you getting? This small changes you need to consider here. So if that is the case, it is again x minus 4 equal to 8 minus x. Now you can solve it, x equal to 6. Very important and very easy, friend. Okay, just you need to analyze some basic laws and rules. Next, if you see, if 3 to the power a equal to this much, find the value of 3 to the power 2a minus 10. Now this type of question asked many a times. Okay, how we can solve it? Now here is the value it is given, 3 to the power a equal to 2187. Now you need to find it out that this 2187, how it is related to 3 to the power something. This is what the case. If you can analyze it, so you can just put it in that way, simply equal to this. And always, if the question asks in this way, there is always a relation between these two. Yeah. So if that is the case, you can put it into this form. So now I can write 6 as this much. Okay. So if you solve it, you got this answer. Here we are simply finding a value, and a is 6. So you are putting 3 to the power a. A is 6. 2 into 6 minus 10. Next, 5 to the power 2x minus 3, that is equal to 5 to the power cube to the power 1, 2, 3, 1. Then you need to find the value of x. So again, we know here, if you putting this 1 to the power 2 to the power 3, if that is the case, so if we can put it in that way also. Okay, so if that is the case, just take the power because power is same and you can solve it. Next, friend, somewhat critical, difficulty level is high. You need to simplify it. That is 5 into 125 to the power n plus 1 plus 25 into 5 to the power 3 n minus 1 upon 8 into 5 to the power 3 by n (8 into 5 to the power 3n minus 5 into 125 to the power n. So here, if that is the case, how we can solve it? See, so you can represent this 125 as 5 cube. I hope you are getting, and this 25 as 5 square. Yes, and here if you see, it is also represented as 5 to the power cube. And if you can find it out, because see, 125 can be represented as 5 to the power 3, okay, to the power n. So 5 to the power 3 to the power n can be represented as 5 to the power 3n. If that is the case, again you got some common here. So you can just remove the common term. You got 8 minus 5 here. And here also, the common term you can put it here. Okay, you can split that form. Now, if you simplify it, you got this answer. Very easy. Okay, and last, today's numerical, this has been asked in GATE 2017. Again, it is on simplify. It is given that 16 to the power minus 9 by 4 into 125 to the power 3 to the power, whole power is minus 1 by 3. Find the value. My friend, here you need to put it into a simple way, like whatever the small digit you can find it out. So we can now write 16 as 2 to the power 4 into minus 9 by 4, and 125 can be represented 5 to the power cube. Yes. Now if you see here, now 2 to the power 4 to the power minus 9 by 4, friend. Okay, so this both get cancelled. Okay, you got 2 to the power minus 9, and here again this is also okay, because 9 you can simply represent as 3 square, so it will be 1 minus 1 upon 3 into 3. Okay, so this get cancelled with this both, so you got only minus 1. So answer will be this thing. Okay, so friend, thank you for your attention. Hope we have gone with a simple first basic concept, then formulas, and then n numbers of numerical. I have taken more than 10 numericals in each, and each of different category, each of different difficulty level. So from this, it is clear that if you understand, or if you have the basic concept like laws of indices, laws of surds, and you know the logarithm rules, then you can simply attain all the questions of exponential log, and it is very easy. ये देखने के लिए थोड़े से hard होते हैं, but it is very easy to solve it. Okay, so thank you for your patience hearing. See you in the next session. Till then, have a goodbye and have a nice day. Thank you.